welcome to K2P classes. Today we are going to study statistics. In statistics, today's topic is mean. Our class objective is definition of mean, mean of frequency distributed data, mean by assumed mean method, mean by step deviation method. Now, let us first define what is statistics. There are so many classical definitions of statistics, but for class 9 and 10 students, statistics can be defined as a study of the collection, analysis, organization, interpretations and presentation of data. Now the key word here is data. Now see, what is mean? Mean is the number which is obtained by adding the values of all the items of a series and dividing the total by the number of items. If x1, x2, x3 and xn are n values of variable x, then the arithmetic mean of these values is defined as mean equal to x1 plus x2 plus x3 plus ... up to xn divided by n. Symbolically, it can be written as x bar is sigma xi, I from 1 to n divided by n. Now, few things we have to understand here clearly. Mean, which is also called average in the layman language, we say average also. Now, when we say mean, it actually means arithmetic mean. There are two other kind of mean: geometric mean, harmonic mean, which is not the subject matter of this class. So, when we say simply mean, it is arithmetic mean. More specifically, example: a score of Dhoni in the last 7 one-day matches are as below: 151, 124, 132, 170, 146, 124 and 113. It is a dream score because no batsman can make 7 consecutive centuries, but for the sake of example we have taken this. Now the question is, what is Dhoni's run average in the last 7 one-day matches? Simply, we will add all the 7 runs and divide it by 7. So, it is 137.14. Now, what is the use of mean? The simplest use is to measure or compare two things. Suppose we are in the selection committee of Indian cricket team and we have to select 2 batsmen. So what will we see? What is the average of the 2 batsmen? And mathematically we will select a batsman whose average is more. It may not be true in the practical situation because there are many things like how consistent the batsman is batting and what is the ability to play in the pressure situations. But by simple measure, we will take a person, player whose average is more. Now, the second questions. The first 10 student of class 10A scored the following mark in second unit test: 35, 30, 32, 40, 35, 40, 25, 20, 25, 30. What is the mean of marks of the 10 students? You can use your calculator. I'm giving you 10 seconds. In the meantime, I would like to say, mean is a very, very dangerous sometimes. Suppose the comfortable temperature for a person is 23 degrees centigrade, and a person, one leg is in 0 degrees centigrade and the another leg is in 46 degrees centigrade. Statistically, if you see, the average temperature of the two legs are 23. So we can conclude that the person is in very, very comfortable situation. But in practically, both of his legs are uncomfortable. So don't simply apply average. You have to apply more intelligence on this. So, okay, what is the answer of these questions? 31.2. Now, I'm giving a series here. Mean of 252, 362, 5235. So how to find out? We will add everything and divide by 10. Then we will put all same number side by side. And then we can write like 2 plus 2 plus 2 plus 2 is 4 into 2 as well. 3 plus 3, 2 into 3. 5 plus 5 plus 5, 3 into 5. 6 can be written as 1 by 6. So this table is called frequency distributions. You write all unique numbers in the first column. Then write down how many times the number is coming in the series. So 2. 2 is coming 4 times. 1, 2, 3, 4. So write 4. 3 is coming 2 times. So frequency of 3 is 2. Frequency of 5 is 3. Frequency of 6 is 1. And multiply these two things, x and f, fx. Then it is coming 35. So the sum of here it is 35. And sum of frequency is 10. That is number of observations. Then mean can be defined as sigma fx. Sigma means adding. Sigma fx, that is 35 by sigma f. Addition of all the frequency, that is 10, 3.5. So this method of finding mean is called finding mean by frequency distribution. By name it is clear. Frequency distribution. We are distributing the frequency of observation in a table. Now, mean by deviation from the assumed mean. In this method, we assumed a mean. Like here, 3.5 is mean. We can always assume that the mean is 3 or 5, somewhere in between. And then just see this mathematical derivation, sigma x minus a by n. That is the mean of the deviation, equal to sigma x by n minus sigma a by n. A is a constant. So if you add one particular constant by n times, it will become na. Like 2 plus 2 plus 2 plus 2, 4 times. If you add 2, it becomes 4 into 2. That is why sigma A, since A is a constant, it becomes n into A. And we know that sigma x by n is nothing but mean. So n cancel out and it is minus A only. So if we bring this minus A, this side of the equal to sign, it becomes plus A. So we can write x bar, that is mean, equal to A plus sigma x minus A by n. Let us see the example. We are taking a series. X is 97, 105, 120, 50, 110. And the total of x is 482. So how many observations are there? 1, 2, 3, 4, 5. So the mean will be 482 by 5. Right? 96.4. Now we are trying to solve this problem by deviation method. Deviation from assumed mean. Let us assume that the mean is 100. So what will we do? We will subtract each number by 100, that is x minus a. Right? Then this is d. D is the deviations. So 97 minus 100 is minus 3. Here 5, deviation is then 20, minus 50, 10. If you add all the deviations, it becomes minus 18. So from the formula, x bar equal to a. What is a? A is the assumed mean. What is here assumed mean? 100. Then x minus a sigma, that is sum of deviations. The sum of deviation is minus 18. So minus 18 by 5, 96.4. Look, the two means are same, right? So we can say x bar means mean equal to a, assumed mean, plus sigma f x minus a. Just if there is a frequency distribution, we can put here f. Okay, this is for without frequency distribution data. If you apply frequency distributions, you have to put here f. So Guru mantra is mean equal to assumed mean plus mean of deviation. This part. Now let us see that x equal to this and the frequency is 253. So x minus a. We will assume that mean is 2500. So d equal to minus 50, 0 and 50. Then fd, f into x minus a is minus 100, 0, 100. If you add, it is becoming 50. From the formula, mean equal to a. A means assumed mean, plus mean of deviations. So mean of deviation is sigma fd by n. So 2500 plus 5. So actual mean is 2505, 2505. So now the question is, why do you use this method, which is called deviation from assumed mean? This method is used to just make your calculation easy, because when we take the deviations, the big numbers becomes very small, minus 50, 0, 50. So the calculation becomes easy. But if you are calculating a computer or calculator, any method will work. But in the class 9-10 syllabus, there is something called find a mean by deviation from assumed mean, and this is that method. Now, mean of a group data. So what is a group data? When we say that, okay, the distribution is like that in a class, there are 100 students, we can always write down what is the marks of all the hundreds people, and then find out the mean. But suppose it is the number of students are 1,000 or 2,000, 10,000, then it will be very, very difficult to add or deal with marks of all the students. Then we have derived a method which is called group data. So what is group data? Suppose in your class there are 60 students, and number of all the 60 students, marks of all the 60 students are given. So you can write down all the 60 students' marks. Then you can find how many students have got numbers between 0 and 20. 2. How many students have got 20 and 40? That is 15. How many got between 40 and 60? It is 30. How many got between 60 and 80? It is 10. How many got between 80 and 100? It is 3. So this type of data is called group data. What is the difference between group data and the raw data? The raw data, you will find very accurate average. In the group data, you will not find the exact average, but you will find the approximate average. Because here we don't know how many, I know that 2 students have got number between 0 and 20. But whether it is 0, 20, 15, 10, it is not known. But this is the limitation of the group data, and we have to assume that 2 people have got the middle number. What is the middle between 0 and 20? It is 10. Then 10 to 40, it is 30. 40 to 60, 50. 60 to 80, 70. 80 to 100, 90. So these are the middle one of the interval. So now we will assume that 2 students have got 10 number, because there is no method through which you can know what is the exact marks the 2 people have got, whether it is 15, 15, 18, 19. So we can assume. Now this becomes very easy. We can find out the mean of this group data through our previous formula. What is the previous formula? Mean equal to sigma fx by sigma f. So sigma fx, 10 into 20. 10 into 2, 20, 30 into 15, 450, and we can find out this 270. So sigma fx is 2940, sigma f is 60. So mean is sigma fx by sigma f, 2940 by 60, 49. So this is direct method to find out mean of a group data. Why it is direct? We are applying direct formula, sigma fx by f. Now we will find out mean of the group data using assumed mean method. So let the assumed mean here is 50. So why we are taking 50? You must ask the questions. It is just because it is somewhere in middle. Okay. You can think it is 60 also. You can take it is 90 also. You can take 10 also. But if you take somewhere in the middle, the differences will be, absolute value of the differences will be a smaller number, and it will be easier to calculate without computer or without calculator. So I am assuming it is 50 just because it is the middle. You can also assume 30, 70. Why 70, 30? You can assume any number between 10 and 90. You can assume 55, 52, but the result will be same. So I have assumed mean is 50 and I am taking difference from the mean, assumed mean. So 10 minus 50 is minus 40, 30 minus 50 is minus 20, 50 minus 50 is 0, 70 minus 50 is 20, 90 minus 50 is 40. So if you see, numbers are coming smaller numbers, and if we add here again we will get a smaller number. So it is x minus a deviations. We multiply by f. So f into x minus is 80, 300, 0, 200, 180. If we add, we are getting minus 60. So this number is a small. If you take any other number, this number sigma fx minus a would be more. The sum of deviation will be more, and it will be a calculating problem. That is why we take a mean which is nearby in the middle. So what is the formula of mean by division method, assumed mean method? A plus sigma fx minus a by sigma f, that is the mean of the deviation plus assumed mean. So assumed mean is 50, this is minus 60 by 60, minus 1 will come, so 50 minus 1 is 49. So assumed mean method, by assumed mean method, the mean of the group data is coming 49. You can verify this number and this number. This is from the direct method. This is from the assumed mean method. Now we will again simplify the calculation, and it is called a step deviation method. What is step deviation method? Like a deviation, we will see here. We will divide x minus a by class interval. What is the class interval? The class interval is the maximum limit of the class minus minimum limit of the class. So it is minus 2, minus 1, 0, 1, 2. Then f into x minus a into r. That is minus 2 into 2, minus 4. Minus 1 into 15, minus 15. 0, 20, 10, 6. Here look, this number is again smaller than this one. Now the formula will be assumed mean plus mean of step deviations into y. So minus 3 by 60, because this sum is minus 3 into 60 into 20, again it is coming 49. It is very simple. Here look, here it is 10 at 60. So if everywhere common is 20, Why common is 20? Because we are multiplying by this. And why it is 10, 30, 20? Because we are taking the middle one. So here, we are just taking this I from each factor, each expressions. So this method is again very easy to calculate. This is the direct method, this is assumed mean method, and this is a step deviation method. The name is a step deviation because we divide each x minus a by class integral. So, but in all the three, through all the three methods, the mean is same. I hope you have understood here.